Now I'm going to talk about part 3. Uh, for part 3, I acquired a data set from Kaggle. This data set was provided by the King County in Washington, and it includes data for homes sold between May 2014 and 2015. It has the price of the houses, and it also has 18 other features, including the date of sale and the ID of sale. Uh, I have this table here with all the variables in the data set, which I'm going to discuss. So this ID is the unique ID for each record. The date is the date for the sale of the home. The price is the price of each home. And bedrooms is the number of bedrooms. Bathrooms is the number of bathrooms. Square foot living is the square foot area of the living space, and square foot lot is of the whole land. Floors is the number of floors. Waterfront is a dummy variable which basically determines that if there is if the apartment is overlooking the waterfront or not. The view variable is a value between 0 to 4, which tells us how good the view of the property is. The condition variable is a value between 1 to 5, which tells us how good the condition of the apartment is. The grade is a value between 1 to 30, which tells about the quality of construction and design. The square foot above is the square footage of the interior housing space that is above ground level. The square foot basement is the square footage of the interior housing space that is below ground level. Year built is the year when it was built. Year renovated was the year of the house's last renovation. Zip code is the zip code of the area. We have latitude and longitude. And then we have square foot living 15, which is the square footage of interior housing living space for the nearest 15 neighbors. And similarly for the lot, the final variable. So in this data set, I'll move on to my Jupyter notebook here. So first of all, I loaded the data set into a data frame. And after that, I checked for all the numeric values. If any of them have zeros, I marked them as null so that I can then take them out. I also looked into the unique values of bedrooms, and I found that there are some unusual values in there, like this 33 here. So it's very uncommon actually for some house to have 33 bedrooms. So I assumed that this might be some kind of mistake in the data set. So I also replaced this 33 with a null, and then I printed to see how many null values are there. And after that, I dropped all these null values so that the data set is clean and there are no unusual values. And then I printed out the head of the data set to evaluate it. After that, I pre-processed the data to make it better for our statistical analysis, as I'm going to be using the same data set in the next parts. So to make it easier for me, since we have this date field, but it does not seem to be a very useful field. So instead of date, I created 2 new variables, year sold and month sold from this date. And then we have this year built variable in the data set, which is when the house was built. I took out the age variable from this year built. And then we have this year renovated for each record, which tells us whether this house was renovated and when it was renovated. So instead of the year, I transformed it into a new variable renovated, which would be either 0 or 1. 1 means that the house was renovated and 0 means that it was not. Similarly, I did it with the square foot basement, which I transformed it into a basement variable, which tells us whether the basement uh, exists or not. Uh, After that, I exported this dataset as a CSV file uh, so that we can use it in the next parts. In part 4, I used the abalone dataset, which has the following variables. First of all, I load the dataset into the data frame, and then there's only one categorical variables, and I wanted to see if there are any unusual values in there first. So I printed unique values for the sex variable, and it showed me that it had M, F, and I. So if you notice, I is an unusual variable because sex should be either male or female, and I does not tell us anything. So what I did was here, if you see, I replaced I with null values, and also all other numerical values, I checked for if they had 0, I marked them as null. And then I printed to see if there are any null values. It told me that height has 2 null values, which means it had 2 zeros in there. And then sex had 1342 records with I, which means that we need to take them out as well. So I dropped all the null values here, and now we have no null values in our data. Then I export my clean CSV file. After that, I perform exploratory analysis on this data set. And here we can see now that sex has only M and F as their unique values. And since it's a categorical variable, we have to label encode them and convert it to integer values, which I've done here. And after that, you can see that it's 1 and 0 now. And the data type is integer 2. It was object before. So after performing the exploratory analysis, I did some data visualization using histograms, box plots, density plots, and scatter matrices. After that, we separate the input and output values. The first 8 variables are our input values, and the 9th variable is our output value, which we put in Y. And then we split the data set 1/3 for testing and 2/3 for training. After that, we use the training data to build the regression model. And we can see here the coefficients and the intercept values. I've printed it out with names as well. After that, I calculated the R-squared score for this model, which came out to be 0.418. After that, I used these 2 records to predict the age value. The answer I got, I had to add 1.5 in both of them, and I got 11 as the age value for both of my records. In the end, I did k-fold validation on the record, on the model, and I got the negative mean squared error as minus 6.05. In part 6, I used the adult salary dataset, and then I dropped this variable, which is not going to be part of our analysis. While performing the exploratory analysis and looking into the unique values of categorical variables, I found out that there are some values with empty spaces in them, like this, and this income values, and even this question mark. So then I removed all the white spaces, and then if you see the unique values for income, you can see right here there are 4 different values. If you see, less than 5K has 2 values, one with a dot and one without a dot. It should actually be the same value. So I used this replace function to fix all these values. And now here you can see that income now only has the 2 classes we need. After that, I set all the question mark values to null and checked if there are any 0 values for our numeric variables, and set it to null as well. So then we know how many records are null in there, and then we drop these records so that our data set is clean. After that, I export my CSV file for the clean data set. Then I perform my exploratory analysis and check the classification size to see if everything is okay. And then I perform my data visualization. After that, I converted all the categorical variables into numeric values. Then I separated my input and output values by slicing the array. And then I splitted the data set into training and testing. Then using the training model, training data set, I built the model using logistic regression algorithm. And I have the classification report as well. So if you see here, the precision scores for 0, the precision score for 0 is higher than 1. Here 0 means, if we go here, okay, 0 means less than equals to 50K. I just printed out these unique values on both places so that I could match what is what. 0 is less than equals to 50K and 1 is greater than 50K. So the precision for calculating less than equal to 50K is more than greater than 50K, which means that a record which has the value of less than 500K, 50K is can be calculated more accurately as compared to a record which has a value greater than 50K. Then I use these 2 records to predict the income values. And as you see, for the first one, I got 0, which is less than 50K. And for the second one, I got 0 as well, which is less than 50K. And then in the end, I performed the k-fold cross-validation on my model. And I got an accuracy score of 0.820.